Hey, hello, welcome to the show. It's me, John Park, and this is John Park's Workshop. Thank you for stopping by. Thanks for coming and hanging out. We're going to spend a little time together here in the workshop today, building some stuff and talking about some things and looking at some projects and videos and all sorts of fun stuff. If you want to be part of the chat, we have a chat over in YouTube. Hello to Dave Odessa and Beata Graf Avdelhagen. Hello. Howdy, and thanks for stopping by there. And then if you're somewhere where there seems to be no chat going on, but the video is still there, that's true. There's probably not a chat there, but there is a chat, a pervasive one that you can go and check out at our Discord, which is adafruit.it/Discord. That'll get you an instant invite. You can come over, join the server, and look for the live broadcast chat channel right there. Oh my goodness, someone's making Lars shots over there. Good gosh. Terrifying. Creepy. So, hello to Andy Calloway, despite the Larsing. Johnny Bergdahl. Hello, Gary Z. Hey, squid.jpg. Good to see you. Jim Hendrickson. Hello. Hey, C. Grover. And Thin Man and Paul Cutler. I'm glad you all could stop by today. So, what is behind the curtain? Yeah, normally that's the rest of the workshop. Well, mostly like a pegboard and tools and things. And Lars is there. I guess I'll leave him alone. I put these here so that we could appreciate some lighting. And I'm shooting some photos and video for the DMX lighting guide. So I decided to leave that up. And I will probably make use of that a little bit today, and then we're also going to look at this in reverse, look at trying to receive DMX messages on the microcontroller. So far we've been looking at sending DMX messages from the microcontroller out the other way. And that was not as straightforward as I had hoped with the libraries that I've been using, so this will probably be a work in progress, but I will keep you informed along the way, and maybe some people with other experience with other libraries or more experience can talk to some of the issues I'm seeing, particularly with DMX and NeoPixel at the same time, which I had assumed that it would be more straightforward than it is, at least with this library. So that's to come. Also, I have a coupon code for you so you can save some money in the store. I've got a recap of my Tuesday show, the Product Pick Show. I've got a CircuitPython Parsec in the continuing series on Touch I/O, Vector I/O stuff working together hand in hand. And this one's a little setup, teeing up the next one. Speaking of the next one, I will not be broadcasting this show next Thursday on the Thanksgiving holiday here in the U.S., so we will not be live on Thursday, but I'll be back the following week. And I'm not sure about other shows. I believe Tim is going to be doing a Foamy Guy deep dive on the Friday, next Friday after Thanksgiving, but not sure yet about Wednesday shows. So stay tuned to see who's all broadcasting. I am planning to do another Tuesday show, though, this coming Tuesday. So it should be my last one before the Thanksgiving break. What else have I got? I'll show you a little bit about the DMX project, and then we'll see what other shenanigans we get into. So let's kick this off with a coupon code. So Triangulate is your coupon code today. If you want to go to the Adafruit shop and buy some cool stuff, why not save 10%? This is how you do it. Just memorize this or write it down or commit it to a runic scroll. I don't know, but any way you want to, or just go and use it right away if you go to the Adafruit shop, which is that right there, adafruit.com. The shop pops up. Go throw some stuff in your cart that you want, build up a project or projects, and then on the way out in the coupon code slot, you can type in Triangulate, and that'll save you some money there. Let me have a look at what we've got going on in the store. Where's my browser window? There you are. So new products, if you go to what's new up at the top here, you can check these out. We've got this thing on the way. This thumbstick Trinky is coming. It's not out yet. SD card to micro SD extender. Pretty cool for remote-ifying some of your SD card slots on things like a Raspberry Pi. Very helpful. We have these NVMe SSD drives, 256 gigs. So if you're doing a Raspberry Pi project, building up a Raspberry Pi system, and you want bigger, faster than your usual SD card, then pick up a drive. This one's 256 gigs, and you can also get either a NVMe hat or an NVMe base. So the Raspberry Pi M.2 hat plus here, $10. That's going to plug into the Raspberry Pi from the top and gives you a slot there to connect your NVMe SSD. Or you can check out these Pi-Maroni bases. They go underneath, and one of them has slots for 2 drives. I haven't used these, so I can't speak to them, but we got a few options there. So that's a new thing. So you can get 10% off of that. It's pretty nice deal there, as well as some new solar buckboard and solar lithium charger products, and then some of these neat Pebble LED, RGB LEDs that we've got. What are we calling them? Pebbles or seeds? And on and on. So that's just some new stuff, but you can pick up anything you want other than software gift certificates or subscriptions. That's my cue to take a sip. Throw those things in your cart and get 10% off with that coupon code today. It is Triangulate. And let's see, next up, so I've got my show on Tuesdays, which is Product Pick of the Week. And on the show, I give you a little bit of a demo of a thing and a big discount. This past week was no different, so here's a little recap. Check it out. The Feather RP2040 RFM95 LoRa Radio Fruit. These make for amazing packet radio transceivers. So it can send, it can receive. You can solder on a little quarter wave or half wave antenna with just a piece of wire, or you can use this little pigtail coil here. So you can see right behind me on top of that TV there's a little NeoPixel ring and an equivalent set to this. And every time I click this button, I'm just cycling through some colors. Let me bring that LiPo battery plugged in and a little NeoPixel ring plugged in, and the antennas on both of them. They're tuned to the same frequency, and it's very simple to just send a message that tells this code over here to go cycle through the colors there. That right there is my product pick of the week this week. It is the Feather RP2040 RFM95 LoRa Radio Fruit. The gun like crazy there, but hey, why not? Let's jump right into a CircuitPython Parsec. Here we go.
CircuitPython Parsec.
Yeah, buddy, here we are. All right, for the CircuitPython Parsec today, I wanted to show you how you can use touch.io and vector.io to create a triangle drawing tool. So this is the continuing series of me building my own version of Illustrator that runs on a PyPortal, basically. And it's just little pieces at a time. Last week we looked at a rectangle tool. This week we're going to look at actually a bit of a simpler one. I should probably have done this one first. This is how you draw a triangle. So first of all, let's just do a demo. You can see, I'll refocus this a little bit and try to get the glare off of there. There we go. That focus, that looks pretty good. So you can see here I've got three little dots on the screen there, a red, a green, and a blue dot. And when I tap, I'm setting down 1, 2, and 3 vertices, which then create a triangle. So each time I go in, I'm just going to restart. I'm just going to draw a new triangle, so I'm not collecting a bunch of them right now, just one at a time. But wherever I place these points, those become the vertices or edge points or line points of the triangle. And the way this works in CircuitPython, you can see I'm importing vector.io, that does the heavy lifting. I'm also using display.io in concert with that, and Adafruit touchscreen. So we set up the board, and we set up a few colors that we're going to use. And then I'm just placing those points there even to begin with. We can see them at the edge of the screen. Those are 3 little circles. That'll be my vertices. And then I'm creating this list here called my points, which is this tuple of these 3 little sets of points. So it's just a little sliver at the beginning. And then I'm using vector.io polygon to create a triangle. So I have my triangle equals vector.io polygon. What's the color and what's the list of points? In this case, it's just these beginning points. And then I put these into the main group with append, and then I'm going to show that group. Then we initialize the touch screen, and I'm setting up 3 little variables here for storing points. So as you can see, very similar to the circle and the rectangle that we've done in the past. In the main loop, I check for a tap on the screen, and then we take that info, and if the point1 variable was set to none, it's empty, that means this is the first point I'm drawing, then I'm going to cast that to point. I'm going to move the old stuff out of the way, and then I'm going to draw the first point. So first point, I just change its x and y values to wherever I've just touched with the touched on the screen. Then that next point becomes available, point 2, and we do the same thing. We draw that point and point 3, but this time, since we've got a third point, we can put the triangle back into the origin point of 0, 0, 0, since I was moving that off the screen before, and then recreate the triangle or polygon with point 0, xy, or rather 0.1 xy, 0.2 xy, and 0.3 xy, and then we just clear out those state variables. And so that is how you can create a triangle drawing tool inside of CircuitPython, and that is your CircuitPython Parsec.
CircuitPython Parsec.
All right. Okay, so like I've said before, this stuff will work well on any of the touch screens that we have. You might want to check out PyPortal or some of the feather wings that we have, the feather TFT feather wings that also have a touch screen built in. Those would be useful for doing this kind of stuff as well. Okay, moving right along. So I don't have a new Learn guide to go over. I have started working on the DMX intro guide, and what I may do, depending on how some of this stuff I show you today goes, I may actually publish that guide just with the sort of first half, which is how to send DMX messages out to fixtures that can receive them. So as a little recap, if you look at some of this stuff that we've got right here, I'm going to zoom out a little bit and just talk about what some of these pieces and parts are. Let me turn on a spotlight there just to put some light onto the situation. I'm going to stand over there actually. Let me just talk about what the heck is this stuff? What are we talking about? So, oops, Wrong screen. Where is that? That one. There. That one. There. Okay. Ooh, it's in a weird spot. Hold on. There we go. So DMX stands for Digital Multiplex. Is that right? I think so. But it is a standard for stage lighting, theatrical lighting, and it is about the same age and roughly similar in a lot of ways to MIDI. It comes from the early 80s. It sends a serial data string that can be up to 512 bytes. And each of those 512 bytes can correspond to a different channel in the system that can be used by fixtures. So a simple case would be a light that just has one channel, and it can just be bright or dark, 256 levels of fade control, and that would be a fixture that's just on channel 1. We have a RGB lighting set here. These are actually set right now into a 4-channel mode, so that means that we could have 512 divided by 4 different lights being controlled using a typical 512 byte DMX message. These can also be set, I think, in a 7 or 6 channel mode, so they've got a couple extra features, and that's really dependent on the fixture, but that could be anything from you could have a light that has uses a lot of channels, maybe use 16 channels because it has red, green, blue, a separate white. It has a motor that pans, a motor that tilts, a motor that moves a different filter or gobo in front of it, and so on. Things like foggers and other equipment also can use the DMX. It doesn't have to just be lights, but we'll be doing a lot with lights. So typical scenario is this is a little inexpensive, like $40 or $50 DMX controller, DJ style DMX controller that can be run into one light that has one set of addresses set on it. So you can see this one's flashing 1. This one's set in a 4-channel mode, so it's going to take anything that happens on channels 1, 2, 3, and 4. In this case, it's brightness, red, green, blue. And then it passes along the data to the next light. So I have a second cable here going, a little 3-pin XLR cable. This one's set to channel 17, and so that's going to use 17, 18, 19, 20 for, again, fade or brightness, red, green, blue. So we have up till now been looking at sending data from the microcontroller to the lights. So I just want to just look at that again, and then we'll move into the other direction of it. So what I'll do is I'm going to zoom in here so you can see what I'm focusing on. So I'm going to take the receive side out of here just for clarity, just so it's clear what's going on. Oh my God, that thing is really tight on there. Take that out. And I'm not using that controller. I'm going to move that off to the side. I'm going to ignore that set of NeoPixels plugged into there right now too. And I'm going to set my DMX shield. So I have an Arduino Uno here. This would also work with a Metro 328 or other similar AVR board of that sort of vintage. And I'm going to set this into sender rather than receiver mode with a jumper, and I'm going to switch to using GPIO pins instead of the UART pins, and I'm going to plop a different board in there. So this is the board that I have programmed right now with receiver. This is the one I have programmed with sender. So I'm just going to plop that shield on there, and that's just a convenience for me not having to upload software during the show right now. I just put it on 2 different boards. Okay, so right now, this one has a very long XLR cable, which is running into this light. These lights have their own power. These ones happen to be plugged into AC power. So there's only data and a common ground used here. So power is sort of on a per fixture basis. And then I'm going to go ahead and bring this over to the computer so we can plug it in. And I'll point the lights back here so you can just see them on the backdrop. So let's head back over here. And these will plug into USB for power and data. Right now, my code isn't really doing anything on its own. It's just waiting for serial data from the computer to type into it, but that could be kind of any code looping through things, fading, running light patterns, that sort of stuff. So let's take a look at it this way. Oh no, is my mouse... Oh wow, I have a mouse that's been going crazy. It's not... It's not going to let me... Is it this thing? Ah, that is it. My camera finally explains. This has been happening for a day and a half now. I had another macro pad that was plugged in. There we go. That was grabbing control. Okay, so I just noticed in the chat, C. Grover said, hey, there's a white dot on that there XLR cable connector. These were a bunch of spare to C. Grover from their studio cables that he was kind enough to send me. So if you notice white dots of paint on cables, those are ones that I was gifted by C. Grover. And yeah, they're great. So thank you again for this. Good eye. Okay, so let's get the... I'm going to put this view of the world, and I'm going to bring up an Arduino session. And I'm just going to use the serial plotter here, or the serial monitor here, so I can type into it. So let's take a look at this one here that I'm using. And I'm going to plug my... move this screen out of the way a little bit. Excuse me. Okay, so we'll put that where we can see. Okay, so let's give data and power, that's this purple cable here, to this Arduino. So then now it's running on my computer. I'm going to go ahead and select that port and open up the serial monitor. Good. Okay, so that's a sign it's working. It just prompted me with the messaging protocol that's used just in this simple DMX sketch here, this little example sketch. And this is from the DMX simple library that I'm using. And this one just is looking for channels. And pardon me, if you watched Show and Tell last night, this is redundant to what I showed there, but I think it's worth showing again. So if I go and tell it a channel, like channel 1, and a value, actually let's do channel 2, that's red. So 2C, second channel, and then I'll do 255 and write to that value, to that channel. You should see, let me point this light where you can see it. You should see a red mark there. You see me moving it around back there. And I'm going to turn this off just because this camera does better when there's less competition. Let's see. Yeah, you can see that pretty well. In fact, I'll turn off my overheads because then it's a lot easier to see. There we go. Knock everything over. Okay, so you can see that light back there. So that is channel 1, the first light. Let's do the second light. We'll do this one blue. So I'm going to go to channel 17. And again, that was on the fixture level. I have it. You saw the little light blinking on the back of that light. You have little buttons on the lights to say what channel are you going to show up. Most things aren't fixed address. You can, in the DMX world, tell a fixture what to start receiving, what channel to start receiving on. So I'm going to say channel 18, which is red, 19 green, 20 blue. Let's do blue. So 20 channel, not 120, 20 channel, 255 right. So that's full blue. You can see it kind of show up there. I'll point that right right here. So you can see a couple of lights there showing up behind me. And let me see if I can put a better, let's add this camera view. That'll make it a little easier to see what I'm doing. You don't need to see the gizmo at the moment. There we are. So there's the two lights, and so those will mix red, green, blue. We can format these as a longer string just because it's being read with this little serial command that parses out the different sections of it pretty nicely. So I can do a kind of a full line here. I'll say channel 1, and this is the brightness. I'll put it at 200. I don't think it cares if I put commas in there just for clarity. Channel 2, we'll do 0, so no red there. Channel 3, let's do green, sure, 255, full green. And channel 4, we'll do 0, no blue. Hit that, and you can see I just changed that light to green. So right now it's obviously a really clunky interface because it's just me typing in serial commands. We can at least send them all at once. So if I copy this and paste that, I'll just update this to start on channel 17. And this will be 18, 19, and 20. If I hit that right now, we'll get both lights sending green. You can, I don't know actually if this is frowned upon, but you can set your fixtures to be the same channel. So if we had a bank of 6 of these that we actually just wanted to all do the same thing, we can tell the fixture that they're on the same channel as other ones. I think that's legal and fine in DMX. It works, at least in the case I've got here. But in this case, I'm going to set them to some different colors. So let's take the red up on this one and hit enter. And so you can see now I've got kind of a yellow light there because I'm mixing. Oh, thank you. Someone told me the Parsec code is showing up, not the not the Arduino code that I'm trying to show you. Okay, let's do it. That, and yeah, that was my bad. I got to move the main camera to a different layer here so that it'll show both. Thank you. Okay, so here I'm going to make this bigger. Actually, I'm going to use this tool to make this bigger. There you go. Hopefully you can read that pretty well. So that's my little. David Glaudet says, "Yeah, I was confused in show and tell. I was thinking Arduino size. This must be C, but I see CircuitPython. No. This is Arduino. My bad. I was when I switched cameras, I had the wrong code view showing. Okay, yeah. So this is an Arduino, and that's my little syntax that I have there right now to send 2 lights. So of course you can imagine we could have knobs, dials, distance sensors, kind of anything that you can read on the Arduino being parsed into sending these messages. And they are, I forget the speed, the baud rate of the DMX message. It's pretty fast though, so we can read real-time controls and have the lights updating pretty well. It's decently fast. So I'll put that detail into the guide just for people who are curious what the speed is. So this actually this is a good question from David Glaudet, and this leads into something we're interested in doing. He said, no CircuitPython support for DMX yet. I believe there is a library out there. I haven't tried it, but there exists a library. There exists an example of someone who's created a feather wing, but you can also use a what is it, a Max 483? Let me Google this real quick. chip yourself, but let's see. So DMX feather wing. Someone has created one here. Let's see. So the chip on there is not identified. What's your name, Chip? Oh, I don't know if they're using a standard. Yeah, let's see. Let me do DMX Arduino Shield. This is kind of the starting point for it. I'm using this Conceptronics one. I think CQ Robot. Yeah, so it's the Max 45 chipset to do the communications. And so Limor is looking into building a feather wing that'll have a couple of 3-pin XLR jacks, both genders, so that we can do in and out. And one of the typical like Max 45 chips on it. And then we'll look into the existing library that's out there, or maybe there's libraries, and take a look at doing our own. So let's see. Let me do DMX CircuitPython. Is this in? I think that might just be a request. Yeah, I think this one is the one I was looking at. So this is Mydana, M-Y-D-A-N-A, and this is Blink DMX equipped light example. So this is a transmitter library for. Looks like they're using a RS-45 driver there and a just a TX pin on it. It happens to be a KB2040. So I think there's a lot of space here to make something cool, and I really like the idea of receiving as well as sending. So in fact, let's use that as a segue to this adventure in receiving. I'm going to switch back over to this, and I can hide that out of there, and let's go back to Arduino here. So DMX receive. So this is what I've been playing with. I'm going to zoom this back out so you can see it. Move that back over there. So I'm going to grab the, I can turn the lights back up first of all. And I'm going to grab that DMX controller and the other Arduino. And let me plug this one in. So the idea behind this is that I want to be able to use stuff like that controller right there to send out DMX messages and then read them on Arduino with the shield and do something like write out to a NeoPixel strand. I happen to have these little heart NeoPixels here. I think there's maybe 16 of them on there. So you can see what I'm going to do is unplug Arduino from power. And I'm not sending DMX. I'm just going to be receiving it. So let's switch out for this other Arduino. Try to get the super skinny stacky header pins in there without bending anyone. It's always a challenge. I always wish someone had made a stacking header that wasn't this long and this thin, but more like a regular. There we go. Squish those back together. And so what I've done is I've taken my NeoPixels and attached them to power, ground, and data on these stacking pins here. Plug unplug that previous thing. And for this, we have a different arrangement of pins because I'm using a different library. This library really wants to use the UART pins, so the shield here lets you switch from pins 3 and 4 over to the UART TXRX. And then I'm going to switch to receiving mode instead of sending mode. And that should work like that. Okay, so now I'm going to take the little DMX DJ controller here. So it needs its own power. It's got like a 12-volt power supply, so I'm going to plug that in. That's just powering the little controller. NeoPixels will be getting 5 volts from the Arduino there. And I'll zoom out this camera so you can see a couple of these things at the same time. Fix that focus. Okay, so you can see at least the controller's there. That's what this cable here is out from DJ controller, DMX controller into DMX shield. I'll power the Arduino, and you can see I've got my NeoPixels lighting up at first, just as a test. So the first thing it does is light up the NeoPixels, and then I have it reading channel 1. So this 512 channel MIDI message comes flying through. And it's just checking channel 1 only right now to see is the value below or above 127. So you can see if I crank the value up, my NeoPixels light up. Oh, and it looks like maybe I'm off by, could this thing have 17? Oh, maybe this has more. Maybe this has like 20. Not sure. Or I might need a resistor on the first one. So off, on. That's all I've got working right now. Obviously, that's not super exciting. We want to get to where we can color mix and fade them up and down. But I just wanted to show you the progress on this. So in this code here, let me make that a little more readable. Hold on. Crop that over there. That should work. Yeah. Okay, so in this code here, I am get the top of it visible, pardon me. There we go. So I'm using the other, there's about 3 or 4 DMX libraries out there for Arduino that work on these kinds of shields. And I was using DMX Simple, but DMX Simple is so simple it just sends. And so I've switched over to this Conceptonetics DMX library for Arduino is its official name. So in Conceptonetics library, I'm also importing NeoPixel and setting up this strand here, which maybe it has. I don't know, let's try. You know, I won't try to flash it right now. I haven't set that up on this machine. But what I've got is right now it thinks it's checking for 10 channels. And again, by the way, I'm switching where I can the verbiage to sender and receiver, which I believe is what. I can't remember if that's what we had for SPI, but some language other than this slave and master, which is the typical language used in DMX. But you will see it in the library just because it's hard-coded there. But there are 10 channels that we can receive, and I have enabled receiving, setting the start address as channel 1. So that's why it's only receiving on this channel 1 right here. And let me see if I can show you that channel at the same time. Yeah. So if you look there, you can see I'm moving the fader on channel 1. This box could be sending that out as channel 17, and nothing will happen. This moves in banks of 16. So there's channel 1. You see channel 2, 3, 4, nothing. Even though we're reading 10 of them right now, I'm actually only checking for that one channel. And maybe in a second here, I'll set this up and see if I can upload code to this from this machine. I just haven't tried it. I was doing it somewhere else. And change that channel number so we can see that in effect. And then we're setting up initially I was checking RGB on here. Oh, I'm so sorry. Did you say the Parsec code window is back? No. Are we good? Yeah, we're good. This is the Arduino window. Double checking. Paranoid now. So the first of many issues I've seen are, even though with this setup, if I only push code that's sending NeoPixel code, it works great, and I'm getting RGB. It seems there's some conflict with at least this particular library and NeoPixel. So it seems I'm unable to send to individual pixels. I'm only able to do a fill to the whole strand. And it seems I'm only able to send one channel. And it seems like the channel that wants to show up is the blue channel. And it's also reversing the order. So I'm actually sending it red, because this is ordered as red, green, blue in the code. And it sends that over to blue channel. So there's clearly a whole bunch of stuff going on mucking up the works with NeoPixel and this DMX library, maybe in particular, or maybe some DMX stuff in general. So we'll see. This could be a bust, but I'm gonna do a lot. I have only just scratched the surface of attempting to talk to this thing. That said, I was at least glad to see that I can receive a DMX message, and I can tell that it's above 127. That's when it switches over. Right there. Should be able to see. So at 127 on the little, this is the value I'm sending. Right as I cross that threshold, then it blinks up the NeoPixel. So that part's working. So it's checking the channel address, which is channel 1 that it's checking. And if that's greater than a value of 127, then it's setting it high. Otherwise, it's setting it low. So what I want to do is, first of all, let's see if I can get this flashing this board from here. So I'll just set my board and my address. Those look good. This board with this library using UART TXRX has problems uploading to the board when the shield is enabled. So what I'm going to do is disable the shield just with this little jumper here. And now I should be able to change. Let's try changing the channel that we're writing to. Actually, just to see that I've got everything working, I'm just going to set the NeoPixel strand to like 4 pixels. And let's try pushing that up there. Oh, what did it say? What's its problem? Do I not have that library available on this machine? That's possible. Let me install that. Yeah, this is not as simple as CircuitPython when I start to realize I'm on some different machines and I have a new machine that I just set up, and so I don't even have the libraries. But I'll show you where I'm getting this from. So let me open up. I should be able to see this, maybe. There we go. So Conceptinetics DMX library. It's on SourceForge. I think maybe people have forked it and put it on GitHub, but this is where I got it from. And let me make this a little smaller so that I can see it. Code. No, I want files. download latest version. Okay, and then I got to figure out where this this Arduino's libraries are. Comment over in the chat. Somebody said try maybe Neo GRB. Yeah, I'll try some others. I was flipping those around a few different ways to see if I could get it to talk to the color order. And it didn't seem to be working, but I'll try those again once I get this happening. Okay, so it wants, let's see, I'm going to ask Arduino, where are your libraries at? Probably here, user JEP documents Arduino, sure. Okay, so I'm going to put that there. Documents, Arduino, libraries. Let's take that download and put it there and unzip that. Okay, so let's try, I'm not sure if I have to quit Arduino or not. Let's see if we can, yeah, found it, okay. So, it compiled, that's good. Let's try to send it to the board. And I'm just going to power cycle this to make sure that we turn off unused pixels. Okay, good. So there you can see it just lit 4 pixels up. Oh, they're not wanting to come back though. Let me just make sure I'm still plugged in. Okay, good. So 4 pixels lighting. So that's working. I'll set that back to, I try like 18 on here. And I just, the biggest challenge here is remembering that I've got to disable that shield every time I upload, otherwise it hangs and I got a power cycle. Okay, so maybe there's more to it, because this is actually, yeah, this is the first pixel. I suspect that's like I need a resistor or something. Even though this is 5-volt logic and 5-volt powered, but could still need a sacrificial NeoPixel. This is old school Arduino Uno under here. Okay, so now let's see if I switch to like GRB ordering. What does that change? Is it able to talk to a different channel? Let's find out. Yeah, it's able to talk to red. Okay, and it knows that that's red. David, wait, why is it so slow? You change the code and it doesn't instantly run the new code? Yeah, I haven't used Arduino in a while and caught myself just hitting save and wondering why nothing was suddenly happening. So here's this is an interesting thing, and this was a suggestion from Toddbot when I was talking with him earlier about troubleshooting this. He said, hey, one thing you might want to do is put at the beginning of your code a little rainbow check. So this actually should be going red, green, blue, or whatever. You should see 3 colors. But you'll notice when I reset the board here, it just flashes 1 color. If I switch this over to turn on the DMX board, we're getting just the 1 color. So I think something's up. And if anyone is interested in seeing what the library is about, I'm going to paste that into the chats. So that's the library I'm using. So if anyone sees something in that library that raises your suspicions about why it would be having trouble sending NeoPixels, I'd love to know. If I just, since I've got this visible here, let me open up an example NeoPixel strand test. Sure, let's try strand test. So strand test, and I was goofing around with different pins. I happen to have it on A0 right now, so let's just try that. Pixel count of, I think this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it's more. 13, 14, 15. It's like 20, 21, 24. Who knows? Okay, so let's push this up to. Oh, I tried to upload before I had disabled the shield. So let's redo that. So what is this? Yeah, there we go. Okay, so is this going to do? Okay, yeah. So you can see we've got, and this is RGB, right? Not RGBW. Yeah, that's RGB. Okay. So let me go back to this here, and so there was a note in the chat. Squid.jpg said, I think I know. I don't think the API for .fill is RGB. Oh. Am I just screwing up NeoPixel and Arduino? It's been so long. All right, what is the uint C is 0. Oh, okay. So let's try a hex. That'll be easier. Okay. Thank you. Let's try this. Okay, so fill OX FFOOOO OXOOFFOO OXOOOOFF, and then down here I'll just pick one of those, OXFFOOO. And something I wanted to do was actually have it not off when I slide down to the bottom, but a different color. So let's get ambitious and try that. Let's go to blue, OXFFOO, or rather, OOOOFF. All right, let's try that. Okay, let's enable the shield. Green, red, hey, so it was nothing. I'm telling stories. Please ignore everything I said earlier about maybe the DMX library was yelling. I was just using NeoPixel wrong, isn't that it? Okay. Thank you so much, Squid.jpg, and Todd for suggesting hex. Okay. So that is a good start. Now, no idea why. Let me unplug it. I bet that first one is just going to be dark. Yeah, I don't know. Still don't know what pixel 1 or 0, what this guy's story is there. I'm going to ignore that, though. So, hey, okay, we got 2-color fader. Not even a fader, a switch there that happens to be a fader that's switching between binary states of color. Next thing I wanted to try is just read channel 2 instead of channel 1. So I think I can, I'm not going to change the start address. I still want it to start looking at the first DMX address, but I think this syntax will tell it the one I'm looking at is actually channel 2. So again, let's disable the shield. Yay, thank you, SquidJPG. That is so helpful. What a wild goose chase I was on. Okay, so now let's enable the shield. I should really make that a switch. Not looking at channel 1, but this is channel 2, and yay. Okay, so we're able to read channel 2. So that means we should be able to do something like, let's read channel 17. So if I switch this controller to this little mode, little state here, instead of the first bank of 16, I'm now going to read, I think that's the second bank of 16. So that should be 17. Let's try that. And I'll set the number of channels to read to, let's say, 30. I don't know if that's going to cause it any hiccups or slowdowns. I don't think so. I should be able to deal with it. So we should be on the first slider here is, yeah, so that's channel 17 now, and that's what it's reading. So yay. David Gaudet brings up the point in DMX, when you run out of addresses, you start to use a new universe. So yeah, DMX has 512 channels per universe, but you can use multiple universes depending on the equipment and the, I don't know if any of these sort of simple-ish libraries deal nicely with universes. I think maybe they do. And in fact, I saw that Lee Cyborg just published an article in the Newest Make magazine that is about DMX control for like outdoor lighting things, and they may have made mention of universes in there from Arduino. So that's really helpful timing. Lamore just pointed that out to me. She's like, "Hey, go look. There's a brand new article about DMX in Make." So that'll be helpful. So the last thing I want to try then, especially because people have their Arduino NeoPixel hats on, if I want to just control a single NeoPixel on here instead of fill, I was having problems with that. It's probably just because I was using the syntax wrong. So if I, let's try this pixel clear command after we do that little test, pixels show. If I want to use set color, which you can see from my commented out thing, I was trying it before. I think that'll be pixel, let's do pixel 2 just because I have suspicions about pixel 1. It might be 0 indexed, don't know. Do I put OX, FF, FF, OO in here? And yeah, I'll leave the channels alone, and then in here I can maybe go blue. Is that gonna work? Pixel 2, set a color. Let's try it. I'm so glad we did this together today so that people could set me straight on Arduino pixel usage. Okay, so this should be channel 17. Okay, close. What am I doing wrong? So you can see there is just a single pixel lit, and I don't even know which end is the beginning. Is that this guy? Either way, we have a single pixel lit. Bring that in there. That's a good start. This should be 17. Let's see. Set pixel color, show. Todd says, confusing the API for setting a single LED is strip.setPixelColors N RGB, where N is the LED to change, right? So that this should be pixel 2. And RGB is the color values. And I'm assuming this is okay with the parenthesis there, but I'll yank it out. Oh, I know why it wasn't working. I never switched the... Haha. I keep getting bit by that. I never enabled the shield. See, Arduino's running, but the shield itself is disabled itself just to avoid interrupting it. Okay, good. So that works. So the parentheses are fine there. So cool. So now we can light up an individual one. And I think what I'm going to do next is I don't think DMX library I'm using here has a, hey, which channel is that message coming on? Because the message always has every channel in it. So I'll need to write a little loop that will watch for changes coming from a channel. And then I can use, let's say, 20 sliders to fade up 20 different, or switch the colors on 20 different LEDs on this strip. I should be able to start using it that way. So this is great. This is really helpful to do it out loud with you all. I appreciate you joining for that journey there. But that's it. That's where I'm at with this. And I'll be probably, like I said, wrapping up the simple output, writing 2 fixtures part of the guide, and then I'll maybe get that published and then work on this input side of things. Because, you know, there's some interesting stuff. There's obviously there's a lot of big controllers and things out there. There's sound reactive controllers. There are scenes and chases of like series of scenes that you can program right into these. And then being able to write to the microcontroller means not just lighting, because, you know, to be honest, lighting is pretty well covered in DMX circles, but to little motors and gizmos and things that you want to plug in on the other side, servos, steppers, whatever, solenoids, if you want to be able to control things via DMX as like a prop that isn't something you can buy off the shelf, then that's, I think, where it gets a little more interesting to be able to insert the microcontroller in there and DIY your own fixture, essentially. The other thing I have questions about is, are there any libraries or combinations of existing code that would work to filter and massage your data if you wanted to read incoming DMX, do some decision making with the data, and then write out a different message on the other way, sort of like we do with little MIDI boxes. That could be interesting. David Letty says, now I will dream of a DMX Christmas decoration. Hey, that's excellent. Yeah, I'm surprised I haven't seen more of these kind of professional Christmas lighting, holiday lighting things be DMX based. They seem to roll their own protocols a lot of the time, at least from what I've seen. Yeah, WLED is so much easier than a lot of this stuff for sure. So part of this is nostalgia and blast for the past. Part of this is integrating into existing things. But that's a good point, David. All right, let's see if there's not any other things. I'll just say hello to some people who stopped by. Hey, Frankie Boy Power Care and Jerome Frazier and David Bronchi. Hello, hello. Thanks for popping in over here on the YouTube chat. And to everyone over here in the Discord chat, again, thanks for your help. And everyone watching, thanks. Have a really great Thanksgiving holiday if you celebrate that. And good grief, this just showed up, so that seems appropriate. I'll share with you gobble gobble Lars. What the heck? All right, thanks everyone so much. Again, I'll remind you, if you want to go buy some stuff at the store and save some money, your coupon code today is Triangulate. You can use that to get 10% off on anything from the shop that we can put in a box and send to you from Adafruit, so go check that out and use that coupon code to save some money. David, once more with the conversation on DMX, said one of the benefits is distance, since it works on your gigantically long XLR cables, as you saw me fishing them out. Yeah, you can send data a long way. I believe it's a differential pair, so it's fairly immune to noise, and you can get some nice shielded cables. And I'll have info about that in the guide. So, all right, that's it. Thank you everyone so much for Adafruit Industries. I'm John Park. This has been John Park's Workshop, and I will see you in a little while. Bye-bye.
Thank you.